What's up, geometry students? Let's do homework, real world applications of trigonometry. Same stuff we're doing. I'm going to show you two different ways to do every problem, whether you're using the small triangle way or the proportion way. So I'm going to work through it quickly. Trying to find this height. We have this angle. We have this side length. Trying to find the height of the tree. We're starting with pictures at the beginning of this homework. Towards the end of the homework, you need to be able to draw the pictures, so you'll be able to practice that. If you like to do the small triangle method, this would be the sine of 35. This would be the cosine of 35. This would be 1. You are scaling this triangle by a factor of 47 divided by the cosine of 35. So you will need to take this sine 35 value and multiply it by that. So one way is to take sine of 35 and multiply it by 47 over the cosine of 35. The other way is to set up a proportion. You see this is the opposite. This is the adjacent. You would know that the tangent of any triangle, the 35-degree angle divided by 1, would be equivalent to, in this triangle, the opposite over the adjacent. Cross multiply, divide. There's no dividing that needs to happen because when you cross multiply, x is in the numerator. So you see that these two answers are the same. If you type them in, you get the same. Make sure your calculator's in degree mode as always. 47 tangent 35 and sine 35 times 47 divided by cosine 35. Okay, so this 32.90. Okay, 8-foot metal wire attached to a stop sign. How far is the foot of the stop sign to the stake? So how far is this distance? Right here. All right. Small triangle. This is 51 degrees. This is the sine of 51. This is the cosine of 51. This is 1. We just need to scale it by 8. So x is 8 cosine 51, or cosine 51 times 8. If you did the proportion, you'd say this is the adjacent, this is the hypotenuse. You would use cosine of the angle over 1 would equal the adjacent length over the hypotenuse. So this is essentially like your small triangle. This is your big triangle. Multiply by 8, you get the same thing. Cross multiply, divide, or whatever. Solve for x. Find the height of the kite. This height of the kite is the opposite. We are going to have to add 3 to this opposite length to get the full height. Small triangle, 25 degrees. This is the sine of 25. This would be 1. This is the cosine of 25. We can see we're scaling things by 100. So the height, or the opposite side length, would be 100 times the sine of 25. And that is my answer. I didn't plug the previous one into my calculator because we need to be like cool with not plugging it into our calculator. It's like that's the answer, and you would be able to get the answer by plugging that into your calculator. If you were to use a proportion, you'd say, I want to find the opposite. Your answer is this plus 1. And I have the hypotenuse, so I'm going to use sine in SOHCAHTOA. Sine of 25 over 1 is the same as the opposite over the hypotenuse. Cross multiply, divide. There's no dividing because we just get the opposite is 100 sine 25. Don't forget to add 1. All right. Now we are drawing the picture. You got to understand the lengths that we're talking about. We got some dude measures their distance to the base of a tree. So we're back to the tree problem. To be 50 feet. That's that length there. The angle of the elevation to the top of the tree is 60 degrees. Find the height of the tree. Here you go. You can either use a small triangle and scale it, or just set up a proportion and solve. If this is 60 degrees, this is the sine of 60. This is the cosine of 60. This is 1. We can see that 50 is the base length, so we would scale the cosine of 60 by dividing the numbers. So 50 divided by the cosine of 60 is the scale factor. So we would take the sine of 60, this number, and multiply it by 50 over the cosine of 60. Or this is the opposite. This is the adjacent. This is the hypotenuse. I'm saying the height, not the hypotenuse, which might be tricky. The tangent of 60 equals the opposite over the adjacent. Put this over 1, cross multiply, divide. 50 times the tangent of 60 is the same as the sine of 60 times 50 over the cosine of 60. I wonder if we switch into inverse trig functions soon. I think we do. A 20-foot ladder would be this ladder length. Leans against the wall, makes a 70-degree angle with the ground. How high does it reach on the wall? So I'm trying to find this opposite length. Small triangle scaled. This is the sine of 70. This is the cosine of 70. This is 1. Multiply things by 20 to get the opposite length. Or you have opposite that you're trying to find. You have the hypotenuse. Opposite and hypotenuse, you'd use sine. Sine of 70 over 1 correspond with the opposite over the hypotenuse. Cross multiply, divide, you get 20 sine of 70, showing you the 2 ways to do things. $18.793. All right, we start asking about angles soon. Okay, person flying a kite has let out some string. That would be this. This is that. How high is the kite in the air? Cool. Same deal. Small triangle scaled, or set up your proportion. You get that the height, which is not the hypotenuse, but the opposite, or x, if you want to do with x, whatever you want to do, would be the sine of 42 times 50. Person is 2,000 feet from the launch pad of a rocket ship. Cool. When the rocket is 5,000 feet in the air, what is the angle of elevation between the person and the rocket ship? Introducing this variable theta. Theta is what Greeks have used for angles since the Greeks started with mathematics. So we can start using theta. We can also use x. We can also use a star, whatever we want. But we're going to use theta. And we will say, okay, we have the opposite. We have the adjacent. Remember that the trig function of an angle gives you a ratio, and that the inverse trig function of a ratio would give you an angle. Okay, so we plug in angles into SOHCAHTOA. We plug in ratios into inverse sine, inverse cosine, inverse tangent. So since I have opposite and adjacent, I would use inverse tangent. And know that you don't need 5,000 over 2,000 because you can just scale it down and make it 5 over 2. Make it 2.5 over 1. Regardless, you get this 68-degree angle. We have this in our notes. Oops. $80-foot tall building. Person is 200 feet away. What is the angle of depression? Now, here's the key. This would be the angle of depression, which corresponds to the angle of elevation from the other person's perspective. This is the angle of depression. This would be the angle of elevation. You can either use this triangle and know that this would be 80 and this would be 200, or you would use this triangle, just knowing that you would be using this angle with 80 and 200. Regardless, the angle would be the tan inverse of 80 over 200, the opposite over the adjacent. $21.8 degrees. Okay, I actually took this off the internet, so these are all accurate, somewhat accurate. Dimensions of the Golden Gate Bridge. The start of the bridge to the first pillar is 345 meters. This angle of elevation is 33.69. How tall is the first pillar? What is this height? What is this length? What is X? We've done this before. You can either start with your small triangle, 33.69. This is the sine of 33.69. This is the cosine of 33.69. This is 1. You would be able to say 345 divided by the cosine of 33.69 is your scale factor. And you would take the sine of 33.69 and multiply that by the scale factor, 34.5 divided by the cosine of 33.69. Or we could use tangent. We could say that the tangent of 33.69 in any triangle would be equivalent to the tangent in this triangle, which is the opposite over the adjacent. And you would multiply by 345, and you don't have to divide by anything because you divide by 1. So you'd say that this is the same as 345 times the tangent of 33.69. Cool. $229 meters. It's really 230 meters. The architect wants his scale drawing to have a height of 0.3 meters. So we want a scale drawing to have a height of 0.3 meters. How would he label the base section? Well, it's the same deal. You just like start with this scale. Scale factor would be 0.3 over the sine of 33.69. So it would take the cosine of 33.69 and multiply it by 3 over the sine of 33.69. That's one way to find this length x. Or you just start with this triangle and you would say the tangent, finally got something where we have to cross multiply and divide. Tangent of 33.69 equals 0.3 over x. Put this over a 1. Cross multiply. Now we have to divide by the tangent of 33.69. $4.5. It's supposed to be a 0.3. 0.45. Cool. All right. I mean, you either are doing this and you're like, easy. This is easy. I've been doing this. It's starting to get repetitive. It's the last lesson where it's repetitive. Or you haven't been doing this long and you've just been copying stuff down because it's an easy lesson to just copy down answers, but you really don't know what you're doing. So hopefully you're in the former, not the latter. And starting next class, we are actually not using our calculator. We are going to focus on 2 different types of triangles, a 30, 60, 90 triangle and a 45, 45, 90 triangle, whose side lengths we just need to understand always without having a calculator and pressing sine and cosine of 30 degrees or 60 degrees. Okay. Okay. Peace.